So, dear audience, let me introduce you Anand Ranganathan, who is co-founder and chief AI officer at Unscramble, and data scientist, and holds PhD in computer science from University of Illinois. And Anand will talk about natural language querying and conversational analytics. Anand, go ahead. Microphone is yours.
All right, thank you so much, Ross. Thanks for inviting me to present at this very interesting conference, the Data Science Online Conference, and hope you all can see my screen and hear me well as well. So today I want to talk to you about a new paradigm that we've been working on at Unscramble on how people can explore data and get insights from data. So this is using something called natural language queries and conversational analytics. So let's introduce myself as I'm the Chief AI Officer at Unscramble. Unscramble is a startup that's about 6 years old now. We've been focusing on how to bridge the gap between non-technical business users and users even in the general public and data sets. So today, in many enterprises, it often takes days, if not weeks, for users and business users to get access to interesting data, and you want to reduce that to minutes. And we think that natural language queries is the way to go about it. So let me go ahead. So the problem we're trying to solve is that in many enterprises today, data adoption remains low and it continues to drop. So only 31% of businesses think that they are as data-driven as they need to be. Many business users don't know how to get to data. They may not know the right programming languages, whether it's SQL or Python or other BI tools to get to the data. So they depend on data teams or analytics teams to get them insights, and which can take a long time. In some other enterprises, we've seen this issue called death by dashboards, where each new request for a new kind of data results in a dashboard creation or report creation activity. And that also becomes now very difficult to maintain and scale. And even as data scientists, very often when data scientists do some analysis for a given customer or for a given use case, that data science result becomes usually shown as a set of charts or a set of or graphics, and then lost. And then finally, when business users want to explore it further, they can't do it themselves. They can't actually dig into, say, what's the meaning of different predictions or how to make use of it. So overall, while data there's lots of advances in how to store data, how to analyze data, how to do data science, the last mile problem, which is how do business users actually make use of data and data science to inform the decisions, is still broken. So what's going on, though, in the last year and a half, many business users, while they struggle to get access to data, they're becoming very good in using collaboration tools like Microsoft Teams, Slack, Zoom, and others, right? So more and more users are spending more and more time on these platforms. However, at this point, data is not available on these platforms. So there's still a gap between users and data. And the same gap exists not just in the business space, enterprise space, but even for general public. Right? So even general public often struggles to get access to interesting insights from data. So they have to rely on news articles or social media to get them information about everything from, say, COVID to social issues to everything, right? So while lots of cities and states and the governments and different enterprises have made open, interesting data sets, most of the public can't really make use of that. They can't really understand what the data is saying themselves without relying on somebody else to interpret it for them. So today, what happens is that let me move out of the way, is that most users get their insights from dashboards or reports, right? So the most common way for people to showcase insights is you create a report or a dashboard, or even sometimes just the form of a notebook. And a user would look at that or at report or dashboard and try to make sense of what's going on. But dashboards are limited, right? So they are limited because you can't drill down into dashboards in different ways. So if you want to ask a different question, and the dashboard has not been programmed to offer some kind of drill down, you can't drill down that way. So there's limitations in how much dashboards can serve users. The other big issue with dashboards is that they tend to be representative of somebody's opinion, right? So the dashboard creator is often like an artist. That artist is taking raw data and coming up with interesting charts or insights and presenting it in a fancy way in a dashboard. But that's like an artist, right? So an art is generally biased. So usually dashboards will have the implicit biases that the creator might have, right? And because of that, it's often easy to create fake stats and fake news, or at least mislead users who may not know what assumptions the dashboard creator might have in mind. So because of those problems, we think that the whole business intelligence analytics space is slowly moving towards something called the age of the augmented consumer, where it becomes much more easier for users to be able to explore data using data stories, using natural language analytics, getting personalized insights. So this is a slide from Gartner, which is saying that the whole business intelligence space has been slowly moving from semantic layer platforms to visual discovery platforms to something called augmented analytics, which is where we are today. And slowly we'll hit the age of the augmented consumer, right? Where the consumer in this case is a business user or the general public that wants to get insights from data. So our approach to this at Unscramble has been to drive some progress in this space called conversational business intelligence and analytics. The whole idea of conversational business intelligence is that we want people to be able to ask questions of the data using text or voice and receive back a natural language or visual analysis of the most interesting insights back for that user. So we don't want people to learn SQL or Python or other languages. You want them to just use plain English to ask questions of the data. And when I say English, I mean all natural languages. So before I jump further, I want to just to clarify that oftentimes two ways of interpreting conversation analytics. One interpretation is analyzing conversations, especially in the context of chatbots or customer service calls. And the other interpretation is accessing insights and analyses through a conversational interface. So for the purposes of this presentation, we're going to be talking conversational analytics as meaning accessing insights and analyses through a conversational interface. So what I'll just spend one slide describing our solution. So we built a bot called Cubo. So Cubo acts as an AI-powered data analyst. So most chatbots today that you may be familiar with, they act as AI-powered or virtual customer service agents or assistants of certain kind. And we want AI to now come into the space of data analysis and data science. So we built a bot called Cubo, which acts as an AI-powered data analyst. And in Cubo, you can have natural language conversations within platforms like Microsoft Teams and others. So you can ask Cubo questions like, what is the revenue by device or by age group this week? Or why does sales go down in a given month? Or why were there fewer acquisitions in February? And Cubo can connect to one or more data sources. Users can converse with Cubo, and most interestingly, users can collaborate with one another while they're exploring data. So let's take an example of what goes on behind the scenes when you ask a question, a natural language question. So let's say we have a data set of, say, biking data, right? And we want to ask a question like, what's the number of trips that occurred in winter 2017 by age and gender? So the whole idea of natural language query is that users can ask questions the way they think of the problem, and the system must be able to map that question finally into a query to a backend database. So at a broad level, there are a few different steps that need to occur, right? So firstly, when you ask a question like number of trips into 2017, we need to be able to tokenize and segment this natural language question into meaningful phrases. So these phrases we call them as entities. So this is called entity recognition and construction. So some of the key phrases here, for instance, are number of trips, winter 2017 by age and gender. And once these are segmented, once the entity is recognized, then the next step is to try to identify the right type of query. How do I convert this into a query, and how do I map these concepts into terms that a database may understand. Because database may not have anything called winter 2017, or database may not have something called number of trips. So how do I map these into appropriate constructs for a database to understand? So some of the things that might need to happen is that first you need to understand, okay, this is a kind of query where there's an aggregation happening, there's a number. Maybe the database doesn't have an age field, but maybe it has a birth year field. So I need to derive age from the birth year field. Maybe gender, there is a field called gender, so that might be good. Winter 2017 now has to be mapped to an appropriate date range, which can be used as a filter to a backend query. And once these mappings are done, then we can generate a SQL query given a given database schema. So that's some of the key steps that are needed to first generate the query. And then once you get the query, then we can pose the query to a backend database, get back the answers, and then present these answers back to users. So those are some of the key steps that might conversational analytics or at least natural language query system might need to take. So I'm actually going to move to a demo now, just to give you a hint of what this looks like. So some of you might be familiar with Microsoft Teams. So if you use Teams, then you can actually find our bot called Cubo in the Teams App Store. So if you search for apps, you'll find Cubo. Once you install Cubo, once you connect it to some backend data sources, you can start asking questions now. Let me start by asking a question like, let's say I'm a CFO of a certain retail chain. I can start asking questions like revenue last year, monthly as an example, right? And behind the scenes, what Cubo needs to do is now interpret this question, like I mentioned before, convert it into, after digging into into what exists in the backend database, try to convert this into a query convert this into a SQL query. So one of the things that often happens is that natural language is ambiguous. So the term revenue itself could mean different things in different contexts for different people. So sometimes revenue can be total sales, or sometimes maybe it's just there's actually a field called revenue. But both of these are reasonable definitions of revenue. Sometimes sales means revenue. So here is asking for the right interpretation. So whenever there's ambiguities, we need to be able to present the options back to users in a given form, in an easy to understand manner. So, but once it's done, once we pick one of the interpretations, we can, it converts this into a SQL query, goes to a backend database, gets back the answer, and shows the answer back to the end user. So one thing we can actually check out is the SQL query that got generated to answer that particular question. So here, for instance, we look at a SQL query. We have a way to do that. We can actually, this is the actual query, is doing a selection as well as a sum of amounts. So a little sort of implicit mapping it does, like I explained to you before, to figure out how to actually compute revenue given the fields present in the database. So in this case, there's an amount field, and then summing the amounts and doing a whole bunch of other filtering as well as grouping by month in order to produce the final results and then display the results as a graph. So one of the key things that we believe conversational analytics is useful for is in digging deeper. So let's say I saw this revenue trend. I can now say, show me for electronics. So I'm a retail chain, and maybe I sell different kinds of products, different categories, which happen to be different categories. And I can now keep digging into this data and see what's how the trend looks. So this is for electronics. It actually looks kind of similar to the previous one, so it's a bit different. Let me say for now, keep digging in, let's say for females. Right? So each time I ask a question of the data, it's going to now keep digging in and seeing what the trend looks like producing the trend at more and more levels of filtering. So now as this is for electronics, for females, let me say in Arizona. So I can keep digging and filtering in different ways. Sometimes the filters also might need joins across different tables. Maybe I say, okay, electronics, let me also add some more, let's say for clothing. Right? So now it's going to now try to figure out how to add in that filter. So one of the things that's happening here is that when you just set clothing, there are actually different interpretations of clothing in the database. So there may be different terms. So the clothing could mean clothing and accessories, a category of clothing and accessories, or a customer segment called baby clothing, or a subcategory called disposable clothing. So depending on what what we actually wanted, we can pick the interpretation that makes sense. And now it's going to try to add that whole filter back over here. So yeah, so now it's saying now just within a few queries, we've gone from a basic high level query on what's total revenue to what is the revenue last year by month for either clothing or for electronics from females. And in this case, it decided to get to Arizona. It decided to do a join with another table called digital campaigns. So yeah, so this is how we believe users will interact with data in the future by just asking questions and keep drilling into the data conversationally. Another thing it can do, for instance, say by age group. So now it's going to say all this same information, not just by month, but also by different age groups of customers. Yeah, so that's our vision of conversation analytics. One thing I want to further say about where we see conversation analytics going is in asking not just what questions, like so far most of the questions are what questions, but even why questions. So let's say we saw something interesting in the trend that the revenue had a big peak in June. I could ask a question like, why is the revenue in June 2020 more? And now behind the scenes, actually going to create a statistical model, a machine learning model to understand what are top factors that can explain revenue. And then build a model, after builds a model, tries to come up with the top factors and then explain those factors in a meaningful fashion back to the end users. So here it says the revenue increased because some of the most interesting things that happened between those 2 months are a big increase in sales of whiskey, a big increase in sales of clothing in general, a big increase in sales from vehicles, a big increase in sales from customer segment called window shoppers. So it automatically dug into different aspects of data to find out what's the most interesting things that happened between those 2 months. So yeah, so that's a quick demo. And finally, the whole idea of this being in a platform like Teams is that groups of people can be chatting with one another while they explore the data. So what I was showing you before was just one person interacting with the data. But now let's say that we have multiple people. So here Dheeraj is asking Joe, can you help me understand sales trend last year? And now different people are chatting with each other while they explore different parts of data. So somebody asked revenue last year monthly. Somebody else said, show me by channel. Somebody else said top 5 product categories. So everybody's looking at the same conversation thread and looking at these results as they fly by, and hence getting a better sense of what the data is actually saying. So yeah, I'll stop the demo here. We can make this interactive. I don't know if there are any questions as yet, but let me move back to the presentation. So I'll spend about 10 minutes more on the presentation, and then we'll spend some time on questions if there are any. So the way the system is set up is that our bots is between users and data sets. And today we support a few different kinds of databases or data sources. To make this happen, there are a few things that need to be configured. So firstly, a bot Cubo needs to be aware of what the backend databases are. It does a crawl of the databases, understands what are the tables, what are the attributes in those tables, what are the relationships, like are the primary keys or foreign keys that might exist. And then a user can go in and add few more pieces of semantic information. Like an example might be that they define terms. So define term like revenue. It's maybe not be something that's in the data set, but I'm going to define revenue as the sum of amounts in a transaction table, as an example. And then now the bot knows how to interpret revenue. So once that all modeling is done, whenever users ask queries to Cubo, Cubo is now going to be able to first figure out which database might have the right answer, and then convert the query, natural language query, to a SQL query that can code against a backend database. It gets back the answers and then presents the answers back to end users in a meaningful fashion. So that is, they already did the demo. But So as we kept building the system, and as we have several users and customers that are using on complex data sets, one of the things that kept intriguing me was we advertise the system, or we talk about the system as an AI powered data analyst. Right? And one of the things about AI is, when can we say something is AI, right? So the typical definition is Turing test. So, so one way of framing the problem of, is a bot a true AI bot in terms of satisfying certain role, we can frame the question as, can a conversational analytics bot be indistinguishable from human data analyst or human data scientist? And so that's one way of thinking about how to design the system and whether it actually is intelligent, intelligent in quotes. So what can so if you think of what are the behaviors of human data analyst, right? So a human data analyst or data scientist does much more than just analyzing the data itself, right? There's a whole bunch of things that humans do when a business user or any user asks them to present some findings from data. So firstly, they have to gather and clarify requirements, because very often those requirements can be ambiguous, can be framed poorly, oftentimes in natural language. Right? Then there's the actual analysis part, and that's only like one part of the whole exercise of the set of behaviors for human data analysts. They have to get to the data, understand what the data is, analyze the data, and produce interesting insights. Then there's a part of how do we present these insights to the users? How do we explain what hypotheses we might have made and how what proofs exist? Then there's a whole notion of collaboratively working with the user to refine the insights so as to actually get to something meaningful and actionable. The humans might also be learning continuously so as to understand the user's preferences and jargon. And then sometimes they also might proactively tell the user about interesting things that they found in the data without actually waiting for the user to ask. So those are some of the behaviors of humans that we might want a bot to imitate if you want to call it an AI-powered data analyst. So let's dig into some of those behaviors a bit more. So one of the things is that users can often ask ambiguous questions and poorly framed questions. Right? So, and it's a task of the personal data analyst, the AI-powered data analyst, to clarify those questions. So handling ambiguity is a necessary part of the whole exercise. Right? So here, for instance, this is an example from an insurance industry. Right? You might ask a question like, number of policies last year. So, and just that simple sounding question actually can be interpreted in many ways. It could be number of policies that are issued last year, number of policies that are active at some point last year. So different ways in which can be interpreted, and the data analyst must be able to understand those interpretations and clarify what the user is actually looking for. Another issue is that most users are not going to be aware of the actual physical data model or the schema, right? So they're going to ask questions the way they won't ask questions without knowing what the data looks like. Right? So let's say there's a data model where you have a few different attributes. So there's a biking data set, for instance, where you have for each trip, there's a start time, a stop time, a trip duration, a birth year, a bike ID, and a user type. Right? So that's a backend data model. The human might ask a question like, what's the total number of rides by age group? Right? And now that there's a gap between the terms the human uses and the actual data present here. Right? So, or another question might be, what's the ADPU? Where ADPU is some jargon they put in this space in the last 6 months. Right. So again, here the data analyst must know what is ADPU and how does it relate to what data is present here, if at all it relates to the data present here. In many cases, maybe it's not. Maybe the data doesn't exist to calculate this. So what needs to happen? How do we bridge the semantic gap between users' questions, users who don't know anything about the data, and the actual data model? Right. So the way we approach it is that we define a logical data model where those definitions must be first made. So for instance, the definition must be made that ADPU, which stands for average duration per user, is defined as, say, the sum of all the trips divided by the sum of the durations of all the trips divided by the number of distinct users, as an example. And then there might be mappings that either are automatically or human or inferred or specified by humans. So for instance, the age, right? So age might need to be derived from birth year in some way. or start time and stop time, or something like very old customers. Very old customers might need to be defined by a human in terms of what's the age range or age group that might classify customers being very old. So this logical data model underpins a lot of the bot in terms of how it understands users' questions and interprets them in the context of the physical data model. So one thing that we think is the conversational analytics systems are pretty good for, and humans often do, is iteratively refine analyses. So I showed you before, like I started the question like revenue, and I kept digging into that, asking questions more and more until I found some interesting thing that I could use. So here, for instance, something similar is happening where somebody is asking a question: how many bike trips were there? How many in Jan? How many longer than 15 minutes? Show me by age group. What's the top star station? What's the top star station by total duration of trips? So very often a human data analyst doesn't just produce one answer, right? Very often they produce an answer. The business user might say, what about this? What about that? And there's this whole collaboration that goes on between a business user and human data analyst or human data scientist. And a bot, we believe, must be able to support exactly that same process. Another thing that happens naturally is memory, right? So humans remember, what did somebody ask a few months back or a few days back? How does it relate to what they're asking now? And one of the reasons why we thought a chat interface is interesting is because now we have a transcript of the whole interaction of humans with the bot, and the bot just has memory automatically. Finally, there are different kinds of analytics that the human data analyst or data scientist might do. Most analysis starts from descriptive analytics to diagnostic to predictive to prescriptive, right? So starting from what questions to why questions to what next questions to what should I do about the questions, right? And similarly, we think that an AI-powered bot must be able to do this exactly same thing. So we start with what happened, and then why does the revenue go down? Why the number of trips go down? What's the expected prediction or forecast for revenue or something else? How can we drive up revenue? So that's a sequence of questions that you want a bot to be able to answer as well. Collaboration. So very often, people don't work individually; they work in teams. There might be teams of both business users as well as data analysts. And one of the things over here is we want one of the design decisions here was to incorporate this closely in platforms like Microsoft Teams and down the road Slack and others, so that people can explore data collaboratively. Because I think today one of the key limitations in data analysis, data science is the lack of collaboration. Most things are just individual. So even just collaborative notebooks is pretty difficult to actually use effectively. But we're hoping that using things like collaborative platforms like Teams and Slack is one way to achieve collaboration in data exploration. So yeah, that's the end of my slides. So we'd like you all to imagine the future of work especially as it pertains to data exploration and data analysis. And if you're interested in trying out our vision of conversational analytics, feel free to do that. It's either at unscramble.com or keyboard.ai. And yeah, happy to take questions either now or later on if anybody has questions.
Okay, does anybody have questions? You could write it by text in the chat or just ask them by voice. And while question appears, actually, I have one question. And
Sure.
Is there any way to understand what people are asking about, not to clarifying somehow it maybe from context or from person or maybe from previous request or something.
Right. Yeah, no, definitely. There is a kind of a self-learning aspect that needs to be there. And we have some of it in our system, where as the bot keeps interacting with the user, it gets more familiar with what the user means in certain contexts, or what So especially, one of the places where we see a lot of use for that is in handling ambiguities. So for instance, we work with organizations where even the term revenue could mean different things to different users. Some of them it might mean the gross revenue, some of them might mean the net revenue. So a human data scientist, once they have spent some time working with business users, they'll know that when this person says revenue, that typically means the gross revenue as opposed to net revenue. And the same thing with the bot. It needs to, once the user says, okay, the first time they say, what's the revenue, the bot might say, did you mean gross revenue, net revenue? And then once it's a gross revenue a couple of times, the bot should learn, okay, this person, whenever he says revenue or she says revenue, he or she means gross revenue. So yes, there is a sense of learning, what terms the users might use or might prefer using, and how they want answers to be presented. Ideally, as the business user keeps interacting with the bot, firstly, the bot gets more familiar with the business user, but hopefully the business users also get more familiar with the bot in understanding how to ask questions and use the results coming back. So yes, in both directions, I would say there's interesting learning that can happen.
Is there any way to understand context for the bot? For instance.
No, there's definitely ways to understand context, right? So I think I see what you're saying. Let me skip that. So one of the examples of context is in the conversation itself, right? So when, like in the example I showed before, so there's a conversation has a certain flow to it, or has a certain context in it. So if I just said for electronics, by itself, it makes no sense, right? So, but in the context of the conversation, that the conversation is about revenue and monthly, it makes sense. Or if I just said for females, for females without any context, it makes no sense, right? So, but now in the context of the previous questions, it makes sense. So that's the context that the bot keeps maintaining, and it is aware of the current thread of the conversation as part of the context. So some of it has come by so far, and it's able to interpret questions based on that. So that's one kind of context. Of course, many other kind of contexts, like it knows the user, the role of the user, what data the user typically understands, and some of that also comes into play while it tries to understand the users and answer them.
Oh, for instance, there could be a sales representative and CEO and sales representative, and he asks about sales. It's more about quantitative. When CEO asks about sales, it's more about money or something like that.
Exactly. Yeah. So the role of the user is important. So and that's why this conversation thing becomes important, because is interesting, because we know who the user is, because there's a distinct identity, and we know what department they are in or what role they are in. So for instance, when a CEO asks a question, what's the revenue? Typically it means the whole country's revenue. But let's say when the sales representative in, let's say, New York asks a question, more likely if without any other context, without any other information, they might mean the sales in New York that they're responsible for. So yeah, so that's exactly right. So there is a notion of context there as well, where depending on the role of the user, there is probably different correct answers.